in our last lesson we were talking about problems like this where you had to find what the slope was of a given function at a given point. In this case, -1, 2, or 2, 1. What we're going to look at today is the general idea, not just at a single point, but anywhere on the graph. How I can get an expression that will tell me what the slope is at any point. And that's called taking a derivative. And when you hear the word derivative, think slope of a tangent line. Slope, 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 anytime you hear derivative. And these are just some fancy ways that they can say, what is the derivative? What is the slope? You can say d over dx, d dx, f prime of x, or y prime is how we read these. These are just different ways to show it. And all the definition of a derivative is, it should look really familiar from your tangent line problem. The derivative, f prime of x of a function, is just the limit as delta x approaches 0 of this function as x changed. F of x plus delta x minus f of x. So, to show you how this is done, here's an example that we tried to do in class. Find the derivative of f of x equals 3x squared minus 2x. Okay? Always start with the beginning part. F prime of x is always just this. The limit as delta x approaches 0, f of x plus delta x minus f of x all over delta x. Now, all we have to do is plug in for what we know. Well, in this one, f of x plus delta x, that means anywhere I see an x, I'm now going to plug in x plus delta x in its place. So that's how I get this first part here, which I'll highlight here. I'll highlight that part in yellow. That's all just from the first part. This part right here in yellow leads to that part there in yellow. Now, the issue you'd have to subtract f of x. Well, that's really easy. You just write down the function, subtracting it. However, make sure you're subtracting the entire function. I would put it in parentheses to make sure you don't miss a negative sign. And then, yes, all over delta x. From here, all we're going to do is some basic algebra. So, when I do this next line, it'll move for me. Doesn't want to move for me. There we go. This next line, the limit as delta x approaches 0, all I did was I foiled this x plus delta x squared. So what that means is I had x plus delta x times x plus delta x. So when I FOIL, I would have x squared. I'm going to have an x times delta x. I'm going to have another x times delta x, so 2x delta x's, and then a delta x squared as a result from that part. Now, I also need to go and simplify all these. I just left them as they are because I'm going to have to distribute here as well. You can go and distribute and simplify however much you want to in one step. Your next step then, the limit as delta x approaches 0. I'm just going to FOIL this through. I now have 3x squared plus 6x delta x plus 3 delta x squared from this part here in the first. Right here, now I've got to distribute the negative 2. So negative 2x minus 2 delta x, and then this part here, negative 3x squared plus 2x when I distribute that negative through. And remember, this is still all over delta x. And again, we should be looking for things that are going to cancel out. This is always going to happen. We're going to have the 3x squared here canceling out. I have get another color. I have a negative 2x and a positive 2x, so those will cancel each other out. And what am I left with? I now have, still taking a limit, the limit is delta x approaches 0. I have up top a 6x delta x. I have a 3 delta x squared, and I have a minus 2 delta x, all over delta x. So what I'm going to do, I'm going to factor out that delta x. If I factor out a delta x, I'm left with, I still have a 6x from this first term, I still have a 3 delta x from the second term, and I have a minus 2 for the last term. It's still all over delta x. Now, I can cancel out my delta x's, and now I'm able to plug in, my delta x going to 0. Once I cancel, now I should look to plug in. I can now do that. If I plug that in, this whole middle term becomes 0, because 3 times 0 is 0. And my answer, what I'm left with, is this equation, 6x minus 2. That means that no matter where on the graph of that 3x squared minus 2x, I can go plug in and find exactly what the slope is at any point the answer would be 6x minus 2. So if I wanted to know what is the slope, for example, when x equals 0, I just plug in x equaling 0 here, 6 times 0 minus 2, which gives me an answer of negative 2 as the slope. If I want to know what it is when x equals 3, it would be 6 times 3, which is 18, minus 2, which is 16. The slope would be really going uphill at that point. So this is the idea that we're going to be using in terms of understanding what a derivative is and how to find it. Much more examples here to come in the near future.